You are welcome to chemistry class. Today's topic is types of chemical reaction. Chemical reaction is an example of chemical change. Chemical change is a change that not easily reversible. Is a kind of change that new substances are formed. It's a change where there is a change in the mass of substances. Chemical reaction involve all the processes reactant undergo to become products. We are going to be discussing type of this reaction. We are going to look at direct combustion reaction. Number two, displacement reaction. Number three, combustion reaction. Number four, we'll be looking at double combustion reaction. Number five, thermodynamic reaction. Six, reversible reaction. And seven, catalytic reaction. And number eight is going to be oxidation and reduction reaction. I welcome you to this interesting topic. The first one we'll be looking at is direct combination reaction. This type of reaction that takes place when two or more substances combine to form a single substance. To form a single substance. That the reactant will be processing to form a product. In this case, you have directs. The two reactants are combined to form one product. The reactant in this case may be an element combined with another element to form a compound. What is an element? An element is a substance that cannot be split into two or more simpler units by an ordinary chemical process. An example, as we have been taught before, examples are hydrogen, oxygen, nitrogen, iron, sulfur, potassium, copper, etc. Why a compound form when two or more elements combine chemically. So we'll be looking at when element combine with another element to give us a compound. Example here is hydrogen molecule. Hydrogen molecule. Hydrogen molecule, that is H2. The 2 put there is because it's a diatomic. That is why you have that 2. That is as a subscript there. The 2 here is supposed to go down to give us subscript 2, which is hydrogen molecule. Hydrogen molecule. And from here, we'll be having hydrogen molecule combined with oxygen molecule. That is 2H2 plus O2 to give us 2H2O. That is hydrogen molecule plus oxygen molecule will give us 2 mole of water. 2 mole of hydrogen molecule, 1 oxygen molecule will give us 2 mole of water. Another example is iron. Iron, in this case, another element that combine with sulfur directly, and this will give us iron sulfide. The 2 examples are when element combine with another element to give us a compound. The second example is a smaller compound combined with another smaller compound to give us a bigger compound. An example here is what we have between lead 4 oxide. combine with sulfur 4 oxide to give us lead tetraoxosulfate 6. Lead 4 oxide is a compound, sulfur oxide is a compound, and the two combine to give us a bigger compound which we refer to as lead tetraoxosulfate 6. The second type of reaction we are going to look at is displacement reaction. Displacement reaction. This is a type of reaction when one element or group take the position of another in a compound. One element or group of elements will take the position of another element or group in a compound. Element that can displace another are to be the one that is above another element in the electrochemical series, or what we refer to as another one that we call as a activity series. Activity series, when you are talking about metals, the chemical series talking about ion, cation, and anion. Element or radical. What's a radical? A radical is a group of elements which possess charges. Example: ammonium ion, NH4 plus, and you have SO42 minus are example of radicals. Either element or radical display another element or radical depend on their position on the activity series. As I've explained, activity series arrangement of metal from the most reactive to the least reactive. The example here is zinc combined with copper, that's of a 6, and to give us zinc, that's of a 6, plus copper atom. Zinc able to displace copper because zinc is above copper in the activity series. Zinc is above copper in the activity series. That is why zinc can take the place of copper in the compound. The compound here, copper 2 charge of a 6. That's an example of displacement reaction. It's a reaction that one element or group can take the position of another in a compound due to their position in the activity series. Before element can displace another, that element must be the one that is more reactive than the one that it can displace. Zinc is more reactive than copper because zinc is above copper in the activity series. The third type of reaction we'll be looking at is decomposition reaction. This reaction involves the breaking down of single big compound into two or more simpler substances. When it is needed to bring about this decomposition reaction, it is referred to as thermal decomposition. If it is involved, it is otherwise known as thermal. To decompose means a bigger compound break into smaller one. So when the word thermal break here is talking about it is involved. We have example here. The first one is when calcium trioxocarbonate 4 splits to give us calcium oxide plus carbon 4 oxide. Again, calcium trioxocarbonate 4 split to give calcium oxide plus carbon 4 oxide. Second example is lead 2 triazonitrate 5 split into lead 2 oxide plus 4 mole of hydrogen 4 oxide plus 1 mole of oxygen gas. Again, the second example is when lead 2 transmuted 5 split into lead 2 oxide to give plus 4 mole of hydrogen 4 oxide plus 1 mole of oxygen gas. The chemical formula here for lead 5 is Pb in bracket, you have seen it here, NO3 bracket 2, and the product are PbO plus 4NO2 plus O2, while the other one is a CaCO3 to give us CaO plus CO2. The third type of chemical reaction we'll be looking at is referred to as double Gaussian reaction. Again, double Gaussian reaction. In this form reaction, reactants decompose to form new substances by the exchange of their radicals. In this case, you are going to have two reactants that are going to combine and react together, and it's going to give you two products as well. Two reactants to give us two products. Two reactants to give us two products by exchange of radicals. What is the meaning of radicals? As I've said earlier, radicals refer to group of atoms that possess electrical charge, referred to as group of atoms, that is the element. For example, here we have NO3 minus, that's a radical, and we have SO42 minus, another radical. In the first example here, we have KNO3 plus H2SO4 to give KHSO4 plus HNO3. That is potassium trisulfite 5 combined with tetrasulfate 6, and to give us potassium hydrogen trisulfate 6 plus trioxo nitrate 5. How do they exchange the radicals? In the first reactant, NO3 minus is a radical there that was exchanged with SO42 minus. That is the element potassium K is the one that come to where you have H2SO4, while hydrogen come to join NO3 minus. Again, the radical in the first example, that is the first reactant here, NO3 that combine with K, and you have SO4 that combine with hydrogen. So there's going to be exchange of the radicals. K is going to join SO42 minus, and you have one hydrogen that will be left there. We have two hydrogen in H2SO4. One will remain, one will come and join NO, that will now become HNO3. Again, you have two hydrogen in H2SO4. One will remain with SO4 and join K, it becomes KHSO4. While the remaining one will join NO3. That's why you have HNO3. That's the meaning of exchange of radicals. Second example is between silver trisulfite 5 combined with sodium chloride to give us sodium trisulfite 5 plus silver chloride. That is AgNO3 plus NaCl to give NaNO3 plus HCl. The radicals here are NO3 minus and Cl minus. Again, radicals are NO3 minus and Cl minus. Element Ag will combine with Cl minus. That's Ag plus combine with Cl, that's giving you what? AgCl. Y element Ag, that's silver, combined with, is going to exchange with Cl, that will give you AgCl. Na will combine with NaO3 minus to give us NaNO3. Yag will exchange with Cl and give what? AgCl. Again, the exchange radical here, Ag will exchange with Cl, that giving us AgCl. Na will join NaNO3. So this example of double composition reaction, this was discussed under how to form different type of salts. This is a very good example of producing insoluble salt, as have been discussed under acid, base, and salt. If you look at the example here, the second example will give us two types of salts. NaNO3 is soluble, while AgCl is insoluble. Again, NaNO3 is a soluble salt, while AgCl is an insoluble salt. This is a very good method of preparing insoluble salt in laboratory. The fourth type of chemical reaction here is thermal dissociation reaction. That's dissociation reaction means it is going to split, as we have discussed. But in this case, it's going to also involve heat. The difference between this and ordinary decomposition is because in this type of reaction, a molecule split into smaller one by when you apply heat, and this one is a reversible reaction. That's where you have this sign of reversible in between. Reversible reaction means a reaction that can proceed in both directions, from right to the left and reverse back from left to the right. That's example of reversible reaction. We have two examples here. One, ammonium chloride split into ammonia gas and hydrogen chloride gas. Ammonium chloride is a solid which split into ammonia gas, and the second product is hydrogen chloride gas. Hydrogen chloride gas. Hydrogen chloride gas, not aqueous. Hydrogen chloride gas. The second example is N2O4. N2O4 to give us 2 mole of nitrogen 4 oxide. 2 mole of nitrogen 4 oxide. You can see the two examples. The one reactant split into two products, while the second one you have one reactant giving us only one product. Only one product. So this example of thermal dissociation reaction. Number 5 type of chemical reaction we'll be looking at is reversible reaction. Reversible reaction. As you all know, many reactions can proceed in one direction only to produce products which are entirely different from the original species. And as what we have looked at before, the type of reaction under direct combination, displacement, they are all types of reactions that can proceed in one direction only. Why you can see the example we are giving under this type of reaction, the product is different from the reactant. Product is different from the reactant in the fact that when you have reactant, let's say element plus element to give you compound, it's going to be different. For example, hydrogen plus oxygen will give you water. Water is a product. While hydrogen and oxygen are what? Are your reactants. And in this case, there is no possibility of the product reverting to the original substances. In such reaction, they are known as irreversible reaction. That is, when a reaction proceeds from reactant to product and there is no reversible sign there, it is called irreversible reaction. In other way, we have so many other reactions that can proceed in both directions simultaneously. That is, they can go forward, also reverse backward. These reactions are known as reversible reaction. Reversible means it can proceed from right, it can go to the left, or it can go from the left, reverse back to the right. That is, it can go from the reactant to the product, and product reverse to the reactant. Forward, reactant to the product. Backward, product to the reactant. We have two examples here. Nitrogen gas N2 combined with 3 mole of hydrogen gas to give 2 mole of ammonia. Again, N2 plus 3H2 to give us 2 mole of ammonia gas. 1 mole of nitrogen gas combined with 3 mole of hydrogen gas to give us 2 mole of ammonia gas. We can see that the reaction here proceeds from reactant to the product and also can reverse back from product to the reactant. The second example is nitrogen gas combined with oxygen to give 2 mole of nitrogen and 4 oxide. That's what we have here. So in this case, you are going to have 2 mole of oxygen here to balance this reaction. If you look at it now, the first reaction is balanced because you have 2 nitrogen at the reactant and you have 2 nitrogen at the product. The same way goes for hydrogen. 6 mole of hydrogen at the reactant and 6 mole at the product. The second reaction, you have 2 mole of nitrogen at the reactant and you have 2 at the product. While your oxygen, the 2 have to come here to make it 4 oxygen reactant and also 4 oxygen product. Take note, anytime you are looking at a chemical reaction, you balance by looking at the number of atoms at the reactant and the number of atoms at the product. It's very important. Again, look at it again. The first reaction, 2 nitrogen reactants, 2 nitrogen products, balance. 6 hydrogen at the reactant, 3 times 2 will give you 6. Y at the product, also you have 2 times 3 will give you 6. That's balance. The same thing go for the second reaction. Let's go to another reaction you refer to as catalytic reaction. That is a reaction that is being powered by a catalyst. A reaction that involves catalyst. A reaction that catalyst is involved. Before you go further, you must understand what is a catalyst. A catalyst is a substance which alters the rate of chemical reaction, but itself, the catalyst, will remain chemically and quantitatively unchanged at the end of the reaction. Catalyst is substance. It's going to alter. Alter means it can speed up or it can slow the speed of the rate of the reaction. But catalyst will remain chemically. Nothing will change at the end of the reaction, both in quantity and even in the chemical nature of that catalyst. The job of catalyst is only to speed up the rate of reaction or to slow down. Let's look at type of catalyst. Number one, we have organic catalyst. Organic catalysts, these are the enzymes which control the rate of biochemical reaction in living organisms. The word organic means the one that occur in nature. That's why they are referred to as enzyme, the one that we have in the human body. We control the rates of biochemical, the reaction of life that are referred to as biochemical in the living organism. An example of catalysts are, we have DATase. DATase is the type of enzyme which converts starch into the simpler form, which we refer to as glucose, while glucose can be acted on by another enzyme called cymase that can give you ethanol plus carbon 4 oxide. The reaction that this reaction is referred to as fermentation, that is glucose being acted upon by cymase to give you ethanol plus carbon 4 oxide. Another enzyme here is maltase. Maltase is an enzyme which work on maltose. Maltose is an example of disaccharide. What is disaccharide? Is a two molecule of sugar that are referred to as disaccharide. Example disaccharide are maltose, as I've said here. We have fructose and we have sucrose. That's what example. We have lactose. We have lactose, we have sucrose, and we have maltose. So your maltose will give you two molecules of glucose. Two molecules of glucose. While sucrose, the one that we can get from sugarcane, will give you sucrose, will give you what? Fructose plus glucose. Fructose plus glucose. While so the maltase is the one that we are talking about here that will work on the disaccharide we refer to as maltose to break it into two molecules of glucose. Again, maltose will work on maltose to give you glucose plus glucose. Another type of catalyst is referred to as inorganic catalyst. That's the one that manufactured in the laboratory, but the one that is not occur in nature, the one that can refer to as artificial. So this one can be a positive catalyst or it can be a negative, depending on whether they increase the rate of reaction or decrease the rate of reaction. When it decreases, we call it what? Negative catalysis. Or that catalyst is a negative catalyst. When you say catalysis, that is a reaction that catalyst involved. So the negative one are the one that slow down. And the example is this number 2 here. You have 2 mole of H2O2, that is hydrogen peroxide. The enzyme here is that is the one that you have a letter P in this case to complete this. To have, that is, the correct formula here should be tetraoxophosphate 5 phosphate 5 acid. That's the H3PO4. This P is supposed to be in capital letter, not small letter. It should be in capital letter, not small letter. The second type of reaction here is one that's increase the speed. That is why it's called positive catalyst, and that reaction can be referred to as positive catalysis. The example is when potassium chloride 5 decompose. The catalyst here is potassium manganate, tetraoxomanganate 7. That's the catalyst here to give potassium chloride, and is going to give oxygen gas. So that is 2KClO3. Catalyst is KMnO4, and we give 2KCl plus 3O2. Is going to increase the speed as referred to as positive catalysis. So that's the two types that we have there. Also, catalysts have their own peculiar properties. That's number one. Catalysts alter the rate of chemical reaction. They can only alter. They can only increase the speed or decrease. Increase or decrease. Increase positive, decrease negative. Number two, catalysts remain unchanged. They are not going to be part of the reactant, neither part of the product. They will remain chemically unchanged. Their formula will remain. Also, their quantity will remain at the end of the chemical reaction. Number three, catalysts are specific in action. For example, the enzyme cymase can only work on glucose. The enzyme matase can only work on maltose. And also under inorganic catalyst, the example here, KMnO4 will work on KClO3, while A3PO4 will work on 2 mole of, that is H2O2. Also talking about certain process in chemistry. For example, talking about Haber process, a process that involves ammonia is produced from nitrogen and hydrogen. That we refer to as Haber process. So the catalyst used is called finely divided ion. Finely divided ion, that is ion that has been crushed into powder to improve the surface area of that catalyst. While in the case of contact process, what do you mean of contact process? It's a process where H2SO4 is produced from the step 1, that is where sulfur combines with oxygen to give sulfur oxide. The area that requires catalyst there is when you have SO2 combined with O2 to give us SO3. And the catalyst there is vanadium 5 oxide. That's a V2O5. So they are specific. V2O5 cannot work on ammonia, while iron will not work in the case of contact process. That's the meaning of specific in action. Number 4, catalyst has no effect on the equilibrium of reversible reaction. No effect on the equilibrium of reversible reaction. What is equilibrium? Where the reactant and the product are at equilibrium. That is, they are at the same point. The reactant to the product, they have the same mass. We combine, if you look at the reactant, you look at the product, they are stable. They have the equal number of mass. When you look at them, that referred to as equilibrium. A state where there is no observable change in the rate of referred to as equilibrium. So catalyst can only increase the speed, not affect the equilibrium. It cannot shift, as you have been discussed before. It cannot shift to the right or to the left. That has no effect of the reaction. Number 5, it cannot start a reaction. It cannot start. It can only speed up or slow down. It's not a reactant. Before you can have a chemical reaction, you must have a reactant collide with another reactant to give you product. That has been discussed under what referred to as collision theory. That is, the reactant must collide with another reactant before they can give you product. Catalyst cannot start to react. Number 6, it does not affect type of product form. It doesn't dictate the product form. It can only speed up or slow, as we have discussed. Number 7, when you have a solid catalyst, the rate at which they can work is improved by increasing its surface area. That's why I lay emphasis on that ABBA process. The catalyst used is finely divided iron that has been grinded into powder, that are referred to as finely divided iron. So we are moving now to the last type of chemical reaction, which we refer to as reduction and oxidation. Reduction and oxidation. We are going to define this in time, at least 5 different ways. 5 different ways of defining these terms. Number 1, you can define this in terms of oxygen. Number 1, oxidation is defined as addition of oxygen to a substance. When only added to a substance, is undergo oxidation. While reduction is defined as removal of oxygen. When you remove oxygen from the substance, that substance reduces. Again, when you add oxygen to a substance, that substance oxidizes. When you remove oxygen from the substance, that substance reduces. Example here is Mg, that's magnesium, plus O2. O2 is oxygen gas, to give us 2MgO. To give 2MgO. So Mg here is standing alone. When you look at the product, it has become MgO. So Mg has gained oxygen. That is, from Mg now to become MgO, you can call that oxidation. Why? Mg has gained oxygen. That is referred to as oxidation. But the reverse of that, when you look at Mg coming back to O2 plus Mg, so it has O2, Mg has lost oxygen. That is, if you look at it now, Mg to MgO, oxidation. Mg now coming back as MgO coming back as Mg, that is a reduction. And if you look at what we put here, Ra stands for reducing agent, while OA stands for oxidizing agent. Ra stands for reducing agent, OA stands for oxidizing agent. How do we get this concept? This agent is a substance that reduces another substance, but in that process, itself gets oxidized. That's in this case now, Mg is going to reduce O2. So Mg in that process become oxidized to form MgO. Again, Mg reduces O2 to become MgO. MgO is what? That is what become Mg become oxidized in that process. That is what I refer to as reducing agent. While O2 is going to oxidize Mg. But in that process, it becomes reduced. So any substance that oxidizes in the chemical reaction will serve as reducing agent, while the one that reduces will serve as oxidizing agent. Again, anyone that oxidized, for example, Mg to MgO oxidized, that is reducing agent. While O2 become what? Reduce, that's become your oxidizing agent. The second example here is carbon combined with ZnO2 to give us CO2 plus 2 mole of zinc. Carbon in this case try to take away oxygen from ZnO. CO try to take away oxygen from ZnO, that becomes CO2. Carbon become oxidized, while ZnO losing oxygen, it become reduced. Again, carbon become oxidized by gaining oxygen, while ZnO reduced by losing oxygen. So carbon here using agent, ZnO here is the oxidizing agent. Again, carbon gain oxygen to become CO2, that's oxidized, while ZnO lose oxygen, that's what reduced. That's the second example. Also, you can also define these terms in terms of hydrogen. How do we do that? You can define oxidation as the removal of hydrogen from a substance, removal, taken away. While reduction is when you add hydrogen to a substance. Again, oxidation, you are removing hydrogen from a substance. Reduction, you are adding hydrogen to the substance. Example here is H2S plus Cl2 to give us, that is 2 mole of, that is H2S plus Cl2 to give 2 HCl. H2S is losing hydrogen to become, okay, plus sulfur. Sulfur should be here. Okay, sulfur is somewhere. That is become what? You have H2S plus Cl2